Hi folks, I wanted to show you a quick video on slide rules. This is a Sterling slide rule. Someone on a forum that I frequent was generous enough to donate his slide rules to me so I could learn how to use them and teach the kids how to use them. I think it's a lost art. Not a lot of people use them anymore for practical purposes, but I think it's a great learning tool, and for quick calculations and verifications today it's great to have something like this around and know how to use it. Of course, you've already seen my video on the soroban, which I'm using with the kids to do arithmetic as well. This is very popular in the East. In Japan, they have, this happens to be a Japanese version of soroban. In China, they have competitions and they can do incredible feats of arithmetic with this thing, faster than calculators in a lot of cases. But the slide rule also lets you do a lot of different things. I'm going to go over it in a second, but basically you have multiplication, division, squares and square roots, cubes and cube roots. You can do logarithms, and there's a scale on the back, which you see there, which I've inverted. This thing comes out, by the way, and you can completely flip it around. But that scale inverted has S, L, and T, which is sine, logarithm, and tangent functions. And there are slide rules which, with more functions, you'll find some that are wider, that have more scales, and essentially you can do a lot of the things that a modern calculator does, but by mechanically just moving these things relative to each other and using this thing, the cursor, and you can do all sorts of calculations and get fairly close results, which you're going to see in a moment. Anyway, let me explain to you the parts. So we'll start off here with the Sterling slide rule. You'll see these scales, A, B, C inverted, C, D, and K. They have different functions. For now, we're going to start with multiplication. So what ends up happening is when the 1 is lined up with the 1, you're multiplying the C by D, and you're reading the D scale, and that's a 1. You'll notice there's a bunch of numbers here. You have a 1 repeated. Now that's not actually the next number, like 1, the same as this. That's 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2. And then they didn't write down, 2.1, 2, 3, 4, 5, okay? But that's the same thing, right? So this gap here between 1 and 2 is actually just a 1 jump. And then there's another jump from 2 to 3, then a jump from 2 to 4. And you'll notice that the gaps get smaller and smaller and smaller until you get to the end here, and then it repeats. That one over there is basically the same thing as this one over here. And so the slide rule is essentially a repetitive scale that basically just keeps going like this, and it jumps. You'll notice also that the gap between 1 and 1 here is almost the same size as the gap between 9 and 1. So if you laid a bunch of slide rules end on end like this, okay, you'll see that it's hard to see here, but 5, 6, 7, 8, 9, and then that 1 is there, and then 1.1, 11, right? 12, 13, 14, 15. It basically goes on, and the distance between the next two numbers gets smaller and smaller by a certain ratio. Okay? And that's the secret to the slide rule. So when you line things up, you'll see, for example, if I want to multiply anything by 2, for example, you'll take the C scale and put the 1 up to the 2. Remember, that's not the 2, that's 1.2. So you line it up to the 2, and now all you have to do is read off the D scale. No matter where you are, you're multiplied by 2. So obviously, if you put the 1 here over the 2, 1 times 2 is 2. But look, 5. Sorry, that's not 5. That's 1.5. Remember, that's 2. 2 times 2 is 4. 1.5, right? 1.5 times 2 is 3. 3 times 2 is 6. 4 times 2 is 8. Now, what if I want to multiply, 5 times 2 is not 1, it's 10. So you got to keep in mind, and that's the thing with slide rules, you need to know your factors of 10. So whenever you do any multiplication, you need to keep track of the powers of 10. You usually convert everything to powers of 10 scientific notation, and then you figure out the answer afterwards by multiplying back out of your scientific notation. Now, if you want to do 6 times 2, you can't, because the slide rules end there, right? If this thing kept going, right, you just have another slide rule here, there, and it would line up with, with 1.2 or something, okay? But basically, in this case, you can't. So the other trick to do is if you put this the other way, you say you take that 1 and you slide it this way to line up with 2. So now we're there. So this is still 1 multiplied by 2. And now you want to see there, 5 times 2 is 10. 6 times 2 is 12. Remember, 1.2 or 12. 7 times 2 is 14. 16, 18, and then of course 20. Okay? That could be 10 times 2, 100 times 2 is a 200, 1,000 times 2 is 2,000. So you got to keep track of the zeros where your decimal point is, but the multiplication itself still works out. Now, that's just a simple number. You can do, for example, 3. Here's 3. You put the 1 on the 3. So now everything lines up with a multiplier of 3. So 1 times 3 is 3. 2 times 3 is 6, right? 3 times 3 is 9. Okay? Now you ran out of numbers. You don't have your slide rule continuing. So you go back and you can put this 1 on the 3. Okay? Right there. And you can keep going. What's 3 times 4? 12. See? 1.2 or 12. That's times 5 is 15, 18. Now it gets a little tricky. 3 times 7 is 21. So that's 2. And then 1 tick over is 1. Remember, you have ticks, 10 ticks up to 3. If you go up to, let's say you do 3 times 9, that's 27. See? 21, 2, 3, 4, 5, 6, 7 ticks. Okay? Now, that's the C and D scale. The actual scales A and B, you'll notice, repeat. So you have 1 up to 2, 3, 4, 5, 6, 7, 8, 9, and then you have 1 again, and you'll notice now it keeps going. Again, it repeats. So you can do the same calculations on the B scale and A scale. For example, if I move the 1 to the 3, right there, I have a little bit more freedom, because I can do 1 times 3 is 3, 2 times 3 is 6, 9. Now remember how on the other scale, the C and D, I had to move the slide back the other way? On this one you don't, because you can go on 3 times 9, and then 12 is here, right, times 4. 3 times 4 is 1.2. See the 1? 2 ticks over. 3 times 5 is 15. 3. Remember we did 3 times 9 is 27. See there's a 2, and then 7 smaller ticks over. Okay? And so the convenience with the A and B is that you actually have the same thing happening as C and D, but you've got 2 of them. And then on the K scale, you've got it happening 3 times. Okay? So that's for doing cubes and cube roots. A and B or A and C you can use for squares. So there's different functions here. I'm not going to go into every single one of them, but the slide rule lets you do lots of calculations quickly. Now, the nice thing is you can train yourself. I'm going to just get an app running here. Okay, this is an app. Okay, it's by Jeffrey Renake, Slide Rule Coach. Okay, and you'll notice it has a number of different tests that you can try on your slide rule: multiplication, inversion, compound fractions, and so on, squares. Let's do multiplication. So the way this works is you get something like that. Now you can see that's some complicated mathematical calculation. How would we do that? Well, let's learn, based on what we learned, let's do that calculation. So I'm going to put this down and we'll see if we can do this. Hopefully you can see this. I'm going to adjust the camera and just lower this thing a little bit. Okay, so we're going to start off with 1.2 174. So we know that that's over here. 1.17. So we slide this to here. That's 1.17 roughly times 0.35. So remember, we go up to here until we find 3. This is remember, this is 3.5, right? 0.35 the same as 3.5. So we go to 3, 5, 9. So 359 is going to be almost there, okay? Somewhere around here. And now the answer is 4.2 or something similar to that. So now I zero in on that, so I make, or not, I want it there. So now I use that and I multiply now by 4.93. So where's 4? Okay, so that's now the start point. Okay, and the next calculation, 493. So 493 is somewhere around here, right? And now the answer for that is going to be 2 point something, very small, right? 2 points, just under the 1 tick there. And now the last thing is 894. So I've got to now multiply. I got to zero this again, right? This is back to 1. And my 8 is way out here, so I got to go the other way. I'm going to slide this here. 1. Okay, and then the last number is 894. So there's 8. 8, 9 is right there, and 4 would be just underneath that tick there. Okay, so what's our answer? We're 1.184, let's say. 1.84. Okay, now 1.84 is the answer, but where are we in terms of powers of 10? Well, if you look at this calculation, you've got 49 times 89, so let's say 50 times 100, for example. 50 times 100 is 5,000, right? So that's 3 digits, or 4 digits, 5,000. Now let's imagine 5,000 times about 1 is still about 5,000 times 0.3. So it's about a third. So it's going to be 4 digits. So it's going to be, remember, 1,840 is what I calculated with my slide rule, and I hit return. You'll see that the actual answer was 1858. So I'm off by less than 1% error, okay? And so, and I was doing it pretty crudely. I mean, you can be a little bit more precise. And you can be faster. So, you know, the hard part now is just trying to figure out the magnitude of 10, and there's some tricks to learning that, but let's do the next problem just for example. You have 9, 88, and 0.5. So let's just think where it's going to be roughly. That's 10 times 100 roughly, and about by half. So 10 times 100 is what? 10 times 100 is 1,000. Times half is about 500. So it's going to be 3 digits, our answer. Now let's figure out the exact numbers. So we're going to do this again. So remember, we want to slide our rule to 9, 8. So our 1 goes to 9, 8, 2, 7. So 9, 8 is right there, okay? And the next number is 88.51. So we slide over to 88. Where's our cursor? Okay, 88.51 is here. 88, 85. Hold on, 8, 2, 3, 4, 5, 6, 7, 8. There's 88.51. So it's going to be in the middle here. 88.5 right there, okay? Roughly. This is where the errors get introduced, obviously. Okay, and then we 0.47. So we're going to bring this over to here, because now we're zeroing it back, or resetting the unit to there. And now 4727 is going to be 4,567.2. 7, so roughly around there. Okay, and our answer is, it looks like 4, 1. 4, 1, yeah, 4.1. So remember, we were looking for a number that was roughly about 400 something or 500. So it's going to be 410. So 410. Let's see if we get close. And our target was 411.1. So I'm off by an error of 1/3 of a percent. Okay? So this is, again, just a quick example. Look, here's one more. Let's do this one. And, you know, without having to sit down and multiply all this craziness out, you could figure out the answer within 1%. And some slide rules are even bigger and more precise than this. This is basic. But let's see, just quick rule of thumb, again, where are we going to find our number, right? We got 2 times about 100. So let's say that's 200, right? 200 times 10 is 2,000 times about 1. So it's going to have 4 digits, okay? It's going to be in the 1,000, around 2,000-ish. So let's try this again. Okay, we set our first thing to 1 to 2. Now, I don't know if we set this to 2, right, around there, our 8 is off the scale. So we got to go the other way. So we're going to slide our 1 here to 2, 3, 7. So 1, 2, 3. That's 2.3. And then 7 is going to be almost here, right? Multiplied by 8, 477. So 8, 4 is going to be there. 7, 7 is going to be around there. Now we reset. I'm going to slide this over and put a 1 there. So now the answer we're multiplying, right? The answer is about 2. So we're multiplying that now by 11 or 1192. Now 1192 actually is over here. Sorry, I got to do it this way again. No, I was right. I have to use the C scale. Okay, 1192 is, okay, 1192 is here, 119, so right there, 119, okay, and then 1.3. So we're going to go to here, okay, 1.3, oops, got to keep that close, 1.308. So it's going to be roughly around there, okay? So our answer is 2, okay, 3, that's 3.1, and that's just over the tick mark. So 312, 312, 312, 3.125, we'll say. 3.125. So we said this was in the thousands roughly. So 3.125. Whoops, I didn't type right. 3, no, 3, no, 3, 1, can't see. 3, 1, 2, 2, 5. Okay, so let's just figure this out again. Remember, 2 times about 100 is 200, right? Times 10, 2,000, times about 1 is about 3,000. Okay, let's see, return. So the answer was 3,140, and we got 3,125. Now, that's, again, not bad. We're off by 15 on a number that's in the 3,000. Our error is 0.5, okay? Average error is 0.58%. We've just multiplied out 4-digit numbers that are all 4, digit precision, and or 3-digit. I'm not sure how you count that, but anyway, if you multiply all these out, they're basically, you're within a tiny percentage of error, okay? And you can do this, for inversion, simple fractions, 1/4214. I'm not going to go into all of these, but you've got a lot of different options here to test yourself. Okay, you can do cubes, and each of these things, you do, and then you go next, and it keeps changing the value up here, you see? And you can sit there multiplying out and doing combinations of different calculations. Because the beauty of the slide rule is that you can, once you figure out an answer, you can put your cursor over it and then set your thing up again, or transfer the number and then continue on. So you can do a series of different multiplications. and division, subtraction, well, not so much subtraction, but anything that involves multiplication, division, logs, and so on. So anyway, there you have it. Just a quick look at the slide rule. Definitely useful tool to know how to use, and especially for learning math and keeping a rough idea of what you're getting. The reason I don't like calculators or relying solely on calculators is that even though the calculator is perfect, humans are not. And when you use a calculator and you don't think about your answers or don't have any even estimation of your order of magnitude of your answer, you'll potentially make a mistake. You might type in a digit somewhere wrong, or you might put in a period somewhere wrong, and you'll get some wild answer. You'll type it, you'll think that's the answer, and you can be completely off. If you at least do use your brain a little bit beforehand, or use a slide rule to check yourself. And the same thing with the Soroban, right? It builds up memory, and brain power to do actual calculations. Then you can actually get, more precise and be more sure of your answers, rather than just blindly typing stuff into calculators and not knowing if you've screwed up or not. Sure, you could type the same thing 3 times into a calculator and hopefully you'll get the right answer, but it doesn't build mental power. If somebody who wants to keep their mind exercised and fresh and engaged and try to combat the effects of aging on your human brain, this is another method to keep yourself fresh, and definitely a cheap and effective and easy way to basically practice and learn some interesting tool that unfortunately is from a bygone era. But there you have it. The Soroban, as before, something definitely we should be teaching the kids in school. And the slide rules, which I think should hopefully make a comeback. They're great tools to verify and check answers. They don't have to be used for every single thing, but definitely we should not have dumped them completely from our training just in case. And there you have it. So hope you enjoyed this video. And if you're still using a slide rule, or you want to donate for me, to me, a slide rule, another one that you're not using, please feel free to leave me a message. And if you send it to me, I can feature it on my channel and show some more examples of how slide rules are used. So thanks again for watching, and hope you enjoyed it. Take care, and go out and download a virtual slide rule, okay, for free on your app, an app store, and play around with it, or go to online sources. You can type in virtual slide rule on your browser, and you can actually play around with a virtual slide rule on your web browser on your computer and do the exact same thing. So thanks again for watching, and take care. Bye bye for now.